Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 6.7, rates of change in trigonometric functions. Now, we've done rates of change in two previous units. We did rates of change in polynomial functions, and we did rates of change in rational functions. Now we're going to be doing rates of change in trigonometric functions. Now remember, when it comes to rates of change, if we are asking for the average rate of change, it would be we need 2 points to find the secant. And if we're asking for the instantaneous rate of change, we're going to need 1 point to find the tangent. So we're going to go over a couple questions in this lesson to really drill down what the rates of change in trigonometric functions look like. So let's start off with this question, number 2 from the textbook. For this graph of a function, state 2 points where the function has an instantaneous rate of change in f of x that is 0, a negative value, or positive. So remember, instantaneous rate of change is talking about the IROC, and the IROC always talks about the tangent, okay? So where is the tangent 0? So remember, 0 would mean it's a flat line. So at the max and min, we are going to have the IROC to be 0. So these are the points where we're going to have. So if we look at our graph, the first point is going to be pi over 4. The next point is going to be halfway between pi and 3 pi over 2. So if you wanted to find out what that number is, we can do some side math over here. So I can do pi plus pi over 4. And then obviously we have to get a common denominator. So we end up with 5 pi over 4. So that's what this point is, 5 pi over 4. And that represents that. And we also have this point over here where we can do another side math. We can say 2 pi plus pi over 4. And then we got to multiply top and bottom by 4. So we end up with 8 pi over 4 plus pi over 4, which is 9 pi over 4. So 9 pi over 4. So remember, where is this slope 0? The slope is 0, or the instantaneous rate of change, or the tangent line is 0 when we are at max or mins on the graph. Okay, let's look at the next one. Where is this a negative value? Okay, so a negative value is when the slope of the tangent is negative. So there are actually a lot of places where this slope is negative. So if I look here, anywhere on this side, anywhere over here, the slope would be negative, and anywhere over here, the slope would be negative. So we could literally take a point anywhere on that graph. So I'll take, for example, I'll take the pi over 2 point, where that slope is negative. And I'll also take the 5 pi over 2 point, because that's where the slope is negative. So for the negative value, we have pi over 2 and 5 pi over 2. Now, let's look at the next one. A positive value is just the opposite. So this is where the slope of the tangent is positive. Okay, so where would it be positive? So this is very similar, but we're going to be on the other side. So anywhere here or anywhere here is where it's positive. So these are the positives, these are the negatives, and the zeros are yellow. So where is it positive? We have that. So now we can actually just take a point. So I know over here I'm just going to quickly take this, and that obviously happens at 0. And then I'll also take this right here, which happens at 2 pi. And that's how you do the question. So just a rule of thumb, Remember, instantaneous rate of change has to deal with the tangent of the graph. When it's 0, that means we're at a max or a min. So we have 2 maxes in this equation and 1 min. When it's a negative value, we know the slope is negative, and when it's a positive value, we know the slope is positive. Okay, let's move on to question number 2, or in this case, question number 4 from the textbook. It says, determine the average rate of change. So remember, before we're doing instantaneous rate of change, this is talking about the average rate of change. So the average rate of change, if we remember, has to do with the secant, which includes 2 points, right? And those 2 points are here and here. So what we have to do is we have to say f at pi over 2 minus f at 0 over pi over 2 minus 0. Remember, this is the A-rock formula. So let's do f at pi over 2. Let's find these things individually. So f at pi over 2 is going to be 2 cos pi over 2 minus pi over 3 plus 1. So if we simplify this, we want to get the actual number. So this we're going to multiply by 3. Here we're going to multiply by 2. So what we're going to have is 2 cos 3 pi over 6 minus 2 pi over 6 plus 1, which gives us 2 cos pi over 6 plus 1. So that's going to be your first guy. But we also need to know cos pi over 6. What is cos pi over 6? Do we remember what cos pi over 6 is? Because we can simplify that using special triangles. If you remember, we have a special triangle, pi over 6, pi over 3. This is root 3, 2, and 1. So cos pi over 6 is actually adjacent over hypotenuse, which would be root 3 over 2. Plus 1, and then I can cancel out the 2's, so I'm just left with root 3 plus 1. So that's just what f at pi over 2 is. What about f at 0? Let's do f at 0. It's going to be 2 cos 0 minus pi over 3 plus 1, which is 2 cos negative pi over 3 plus 1. So you got 2 cos negative pi over 3 plus 1. Cool. Now we got to find out what is cos negative pi over 3. So this is interesting. Cos negative pi over 3 is actually going to appear in this quadrant. I'm just going to put it down here so you guys can see it a little better. Cos negative pi over 3 is going to be here. So this is going to be pi over 3. This is going to be pi over 6. So we know that this is going to be root 3, negative root 3. This is going to be 1, and this is going to be 2. So if it's cos of this, it's actually going to be a half. So adjacent over hypotenuse. So this would be adjacent, this would be hypotenuse. So we got 2 times a half, because 1 over 2, adjacent over hypotenuse, plus 1. The 2's cancel, you get 1 plus 1, which is 2. So f at 0 is equal to 2. So remember, it's because we did it in this quadrant because it was cos negative pi over 3, which means that we're going clockwise from the terminal, the principal arm. Cool. So now let's put it together. So f at pi over 2, we'll put it over here. So over here, we have root 3 plus 1 minus 2 all over pi over 2 minus 0, which is just pi over 2. So here we're going to have root 3 minus 1, because the plus 1 minus 2, pi over 2. And then from here, we can say we can multiply the 2 up, so we'll have root 3 minus 1 all over pi. And this right here, guys, is your average rate of change. This is your AROC. And there you have it. So notice how with these kinds of questions, because we're doing trig, sometimes we're going to have to use this special triangle or the cast rule in order to, find out what that cosine, number is. If we don't have that, then we're not able to do that, right? So before in your other units, it was pretty easy. You're just plugging it into the formula and you don't have to do any trig function, trig function methods. But now you have to do those trig function methods. So let's try again with the part B or part C. Let's do this. So with part C, we have the same formula, y equals 2 cos x minus pi over 3 plus 1. And this one is from pi over 3 to pi over 2. So the formula is going to be f at pi over 2 minus f at pi over 3 over pi over 2 minus pi over 3. Now the good news with this is we actually have f at pi over 2 because we did it in the previous question, right? So I'm just going to take that answer because we already have that, so it's a little bit less work. So we got root 3 plus 1 as our f at pi over 2, but we actually have to find f at pi over 3. So let's do f at pi over 3. F at pi over 3 is equal to 2 cos pi over 3 minus pi over 3 plus 1. So you end up with 2 cos 0 plus 1. Now here's interesting. We have a cos 0. Anytime you got a cos 0, you obviously can't do a special triangle or the cast rule because the angle is 0. So what you actually need to do is understand how this cosine function looks like. So we know the cosine function looks like this. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we know it's from 1 to negative 1. So at 0, we're actually at 1. So this is just going to be 2 times 1 plus 1. So it's important to know how the cosine function looks like in cases like this where you can't use the special triangle. So now you have 2 times 1, which is 2, plus 1 is 3. So f at pi over 3 is equal to 3. Now let's put it all together. So let's put it all together. We have root 3 plus 1 minus 3 all over pi over 2 minus pi over 3. What is pi over 2 minus pi over 3? We actually got to do some math for that. So we got to multiply this by 3. We got to multiply this by 2 because we're subtracting fractions. And then we get 3 pi minus 2 pi, which is just pi over 6. And then from here, we can clean it up a little bit more. Root 3 minus 2 over pi over 6. And then we can clean it up again by bringing the 6 up top over pi. And this, my friends, is your average rate of change. And also your answer. So hopefully these two questions, really gave you some perspective. These are definitely questions you can see on a test, so really understand how to do these problems. It's the same process. The main formula is this. The only difference is you have to do this kind of operation for the parts where trig is involved. Okay, great. Let's go to the next question. So the next question is similar, very much similar when it comes to average rate of change, but we're talking about word problems. So let's look at the first one. A ship is docked in a harbor. A ship that is docked in a harbor rises and falls with the waves. The function is this. And it models the vertical movement of the ship where h is in meters and t is in seconds. So here it says determine the average rate of change, okay, so average rate of change in the height of the ship over the first 5 seconds. So what does that mean? That means we're going to be doing it from 0 to 5. So see, sometimes they'll say, oh, the first 5 seconds, and you might think, oh, they only gave me 1 point. That means it's instantaneous rate of change. But no, it tells us in the question that it's average rate of change. So we have to know that that first point is going to be 0 and the second point is going to be 5. So let's do that out. So it's going to be h at 5 minus h at 0 over 5 minus 0. So what is h at 5? And I love doing this separately so you can kind of see it all work out. So h at 5, you plug in 5 and then the 5's cancel out and you're left with sine pi. But what is sine pi? Sine pi, if we look at our sine function, see, this is why you need to know how the sine function looks like. You know that sine pi is going to be here at 0. So we know sine pi is 0. What if we did it for h at 0? We'll have pi over 5 times 0. So we'll end up with sine 0. And what is sine 0? Sine 0 is actually this point, which is also 0. So then we're left with 0 minus 0 over 5, which is 0 meters per second, because that's the average rate of change in the height over the first 5 seconds. That one was pretty straightforward. Now, let's look at B. Part B is talking about the instantaneous rate of change, so IROC, at t equals 6. So we got to remember how we did instantaneous rate of change. Remember, if it's at t equals 6, we use the centered interval method, where we take a point slowly on the right of 6, and we take a point closely on the left of 6, and then we solve like this. So h at 6.01 is going to be equal to sine pi over 5 times 6.01. And then here we can just plug this into our calculator. And remember, you want to make sure your calculator is in radians. Okay? So some of your calculators might be set to degrees from grade 11, but when you're doing trig, you got to make sure your calculator is in radians, okay? And this is how a lot of students mess up, because they put their calculator in degrees and they get all the wrong answers. So make sure your calculator is in radians. And what you end up with here is negative 0.59. Okay, now let's do it for 5.99. We'll have sine pi over 5 times 5.99. Make sure your calculator is in radians again. So we go pi over 5 times 5.99. And you end up with negative 0.58. So now we can plug those back in up here. So we have negative 0.59 minus negative 0.58 all over 0.02. Answer. And what we end up over here is we end up with negative 0.36 meters per second. And this ends up being your instantaneous rate of change. So hopefully this made sense to you guys. It's very much the same similar concepts from what we've learned in the other rates of change videos. If you want to know exactly, a bit of a deeper dive on rates of change, feel free to look at the lessons from chapter 2. There's some videos I have over there that go over what AROC is and what IROC is, if this is something that you're confused on from a fundamental standpoint. But if that's all there is, guys, if you need tutoring, there's a link in our description. Feel free to click that link, get in touch with our team to help you with tutoring in this course, and share these videos. Share them with your friends, your classmates, people who are doing the course, and hopefully we can help support you guys better. Without further ado, I'll see you guys in the next video.